And we're back making mini golf. Or something along those lines. I don't even know. Last I checked, we were tweaking some physics. I read that the scale actually matters, surprisingly so. I believe scale 1 equals 1 meter. I don't know how large a golf ball is. Probably not 1 meter, though. I'd say, you know what, we're gonna Google it. How many centimeters is a golf ball? What's up? Just some late night, you know, coding to relax. What is this? Oh, okay. 4 centimeters is the diameter of a golf ball. So we could say 5. So if that's accurate, then technically this should be like 0.04, right? Because 0.4 would be 40%, would be 40 centimeters. So I don't think that's going to work, though. I think we're going to have to upscale. Like, I don't think I think we can tweak the physics enough that we don't have to have the size to scale. There's no way it'll look good when it's that small. How do I don't know, it feels weird. I feel like we should at least scale it up by 10. So I'm going to do 0.4. Alright, let's give this a quick test, just so I can get my bearings. Yeah. Oh, I remember what I was going to do. I was going to increase the drag so we don't have to do the stupid, like, manual slowdown stuff. Oh, I forgot to do one thing, and that is you guys cannot see any of this text. That's more readable. Where were we? Oh yeah, physics and such. You know what? Hold on. There's a frame selected. That's what it is. I don't know what the whole view thing. Okay, yes, there. That zooms in properly. Now I can. Okay, much better. Now, let me go into Visual Studio. Let me just do this. Scripts. And we are going to do this just for a sec. Now, what I need to do is actually attach the camera. I think there's a shortcut script for that, but I'll just write my own. It's fairly straightforward. But before I do, if we recall correctly, this thing never slows down when it's rolling. It simply just goes and goes and goes. So I think the answer to that is either to increase the drag or the angular drag. Ooh, I think 5 is the sweet spot. I think we can stick with 0 for drag. I was gonna say we can change all this based on the surface. Like, this has a custom surface to it, so you know, short grass or concrete or whatever would be different. What's it called? Like frictions. But this wouldn't change based on this. I mean, we could change it in code, but I'd rather just have this set to a specific value first. So let me experiment. Let me do 3 and maybe like 0.1 normal drag, and then see what happens. I like that, actually. I think when it bounces, it needs to like retain a little bit more of its energy, but that is affected by this. Like, this needs to be maybe 0.9, and then I bet that would. What if we do? Can we do more than 1? What if we do 1? Yeah, no, I'm considering this more like almost like concrete at the moment. Let's go back to the ball. Let's give this an angular drag of 2 instead. No, I think that's good enough. There's a 0, 2, and then we wanted to change the bounciness of the ball to 1 because all these settings are going to be reset as soon as I shut this off. Okay, so bounciness to 1. Ball 0, 2. Yeah. Okay. Now let's attach a camera. So let's take the main I guess the main game camera, align it to the view. How do I do that? Hierarchy. Camera. Move, what's it called? Align with view. Control Shift F. There we go. And yeah, the clipping planes sometimes will mess you up, but it wasn't the problem in this case. Okay, then we want a script on ball that says, first of all, let me erase all this slow time crap. And I don't think we need this, but I'll keep it in there. Keep camera aligned. Follow cam. And eventually we'll get the mouse to like rotate the view with the view or something if you hold down the key. Maybe something like that. Let's store this. Private game object camera. Cam. Private fields get lowercase naming. Cam dot. Oh, we gotta assign it. Cam equals game object dot find main camera. I think it's called. Let me see. Yeah, main camera. Okay. So once we have it, it can be set. Hold on. How do we want to do this? I mean, there will be no other cameras that I can think of yet. So, you know, you were just saying how you don't like long names. So I'm feeling a bit of hypocrisy here. I know, I'm messing with it. Fine, I'll name it main camera. For the audience, main cam. Let's compromise a bit, right? We have that type of relationship. Main cam. Dot transform the camera that is supposed to follow the ball. That's gonna be its name from now on, just saying. You made me go there. Transform.translate. Hey, don't blame me. Now, how do I want to handle this? Do I want to just subtract the difference? Private transform old position. Then every update, well, first of all, I guess we'll assign it here. I'll just transform dot, hold on, dot position. That's, you know, it needs to be a vector 3. Why am I storing a transform? A transform is something that holds all of this crap. So all of its positional and rotational values, as well as some shortcuts for determining what is relatively up and forward. It's got the, you know, quaternions or Euler angles, whatever you want to work with out there. And there's some shortcut methods to do things like look at, or, and of course translate, which is what I'm about to use. I'm just trying to think, do I ever need to look at? I don't need to use the look at function yet, because I'm not rotating the camera. Like, it's just going to be attached to the ball. So we'll use that later once we rotate the camera. Basically, we'll pick a point, we'll rotate it around a sphere, and then we'll move it to a rotation around a sphere. Then we'll look at the ball. Okay, so I guess we don't need to store the entire transform. We just need to store the vector 3 position. Then, at the end of each update, we're going to update that. basically. So now, when we're referring to it before that, we'll have the new position, and we can compare it to the old position, etc. Let's see. .translate. Now, the thing we want to translate to, let's get to that in a second. What we actually want to do is calculate that. So, move to equals. We want to do the difference. I think you can just subtract. I think vector 3 supports the subtraction operator, if I recall. Move to. Let's test this out. Transform dot position minus old position. Let's just do the translate. So move to. Let's see if that does anything. Hopefully it'll keep the camera sticky to it. Although I have no idea if this is the correct formula to use. That is this guy. About to find out though. You know, that's me. That's my biggest defining trait, is overthinking things. I wear it as a badge of honor. Here we go. Okay, well that doesn't work. It's got the right idea. His heart's in the right place. Am I like... Oh, that's even better. It's like doing it on the wrong axis. Okay. The main problem here... I do think I should have rewrote this like I just did. But this is not move to a world position. This is move this much. So yeah. There. We'll just assign the position directly, not translate. I was really hoping to get to like hitting the ball with the mouse today, but I don't think I'm going to now. Oh look, that works. Yay. Cool. That was simple. Once I figured out not to use the translate function, I should have known this. This is like Unity 101. We don't really need old position anymore then, do we? For now. I mean, we might eventually. But I clean up where I can. You know what? Since we're on camera, let's just do, like, rotation and stuff. So, hold down the right mouse button to rotate around the camera, right? So, basically, if this is to get mouse button 1, the camera that is supposed to follow the ball that transformed it rotate around, yeah, I can work with this. I need to separate these out. In fact, no, this is too short. Okay. I think button 1 is the right mouse button. We'll see. Oh, I gotta paste it in there several times. Okay. Times speed. Wait, what is speed? Oh, that's just a hard... Okay, that's fine. I'll calculate this with the mouse distance eventually, but let's see if this even works. Well, I mean, okay. No. How does it... Oh, duh. Of course. It's because of this. And I'll show you what I mean. I'm setting the stupid position each time. So, that's dumb. Not like that. Let's restart. Okay, here we go. What it's supposed to do is this. Now, I don't like that. I think it should level itself. Z needs to be 0. Yes, I could force it to be 0. do 3F for this, by the way. Okay, so let's do this. The camera that is supposed to follow the ball, dot, transform, dot, Euler angles. I know you're not supposed to set these manually. You're supposed to, like, translate and stuff. So equals new vector 3. And we got, what do we got? Well, we got, I hate this. The camera that is supposed to follow the ball, dot, transform, dot, Euler angles, dot, X. This should be 0. Dot Y. So that'll persist its X and Y rotation values and set Z to 0. Hope. Maybe. Yeah, that's better. Okay, we've got a locked camera rotating and everything. Now the problem is we need to move it now. So to keep that in there, we want to do this. While I'm thinking of it though, just to break it up a little bit, private void update camera. Okay. So back to this private vector 3 old position, which is set here and on the last frame of update. Oh, I also need to do this, update camera. So it actually calls it. And this. Then all we have to do is the camera that follows the ball dot transform dot translate transform dot position minus. I thought we tried that. Let's see what happens. Okay, that's right back to square one. That's right, I forgot about that. Okay. Ah, you know what? I think I know what's going on. What it is the things are not lined up the same way. So the translation means something different for the ball than it does the camera. What I mean by that is the main camera's rotation, for example, its Y rotation is 90. Let's just set it to 90. 30, do hard numbers here. Whereas the ball's rotation, I guarantee you, is something like 180 or 270 or 0. That's 90 degrees different. So let me do this and see if that fixes it. And that didn't fix it anyway. Yeah, never mind. Oh, I thought that would have fixed it for sure. That's weird. How do you translate globally? Ah, relative to space.world. There's another parameter in there I wasn't aware of, so this should actually fix it. Maybe. He says for the 3rd time. Yeah, there. That's all we needed to do. And now we can rotate. It's a 3rd-person camera. Yay. There we go. Now the problem is, I want W. Oh, no. What I need to do is get mouse controls in there, and we'll save that for another time. I was going to say I want W to do relative to the camera, but eh. Alright, I think I'm going to call it here. Whoever is hanging out, whoever's lurking, you guys have a good day, a good night, wherever you reside in the world that we call home. Thanks for watching. Catch you later.